everyone. Good afternoon, good evening, whatever time of the day you are watching this. Yeah, I'm here to deal with some calculations in chemistry. Yesterday's assignment, you people have done very well, but I've received questions later. Some of you have reached out to me on how to calculate some of the questions they didn't get. So I want to make a comprehensive explanation about this aspect of chemistry, a few of these calculations. So please pay attention, listen to me carefully. Have your writing materials by your side so that if I write some formulas, you can write them down so that you can practice it later. So let's quickly look at three questions that involved calculations which I sent yesterday. We would answer them very quickly, then I would continue to give more explanations. If you are watching this video for the first time, I'm sorry you may not understand what I'm trying to say. I have some students I'm coaching, I'm preparing them for JAMB this year, and I have a WhatsApp group where we interact, where we learn together, and YouTube is one of the platforms we use among others. We have several other things we use like mental drill, just to make sure that I provide all-round preparation for them so that they can emerge among the top. So if you would like to be part of us, just write interested in the comment section. I will find a way of adding you. Thank you once again. Let's go right into it. So one of the questions I sent yesterday was a question on Gay-Lussac's law. Yes, and the question asked that a gas in a container of volume 10 liters. Sorry, I will not write the question. I will just write out the parameters. So volume 10 liters. This is our volume, 10 liters. And pressure, first pressure, that's P1, is 2.0 atm. I have explained what this atm is. It means atmospheric pressure. And at temperature 300 Kelvin. So T1, first temperature is 300 Kelvin. If the temperature increases to 450 Kelvin, what will be the new pressure? So the temperature, that's T2, has been increased to 450 Kelvin. So the question now is, what is P2? This is unknown. Now, in the video I sent yesterday, I've explained these things very clear, but it's like some of you didn't get it, so I will explain it here, please. Again, what is the formula to calculate this? I have stated it yesterday. P1 over T1 is equal to P2 over T2. This is the formula. It only deals with pressure and temperature. Now look at the parameters that we are given. We are given volume. It's clear you know that we don't need this. So even though it is given, we don't need it in this calculation. Now what are we looking for? We are looking for this P2. I've told you that you need to learn how to change subject of formula. So at this point in time, we need to make P the subject of formula. If you like, you can still substitute your values like this, then before you make P2 the subject of formula. But for me, I would like to make what I'm looking for the subject of formula before I substitute. Alright, let's do that very quickly. So from here, because there is equality sign here, I will cross multiply so that I'll have P1 times T1, I'll have P1 T1, T2 rather, is equal to P2 T1. So this is what I have. Remember, I'm looking for P2, so I will divide both sides by T1, T1. T1 will go with T1. So my formula is P2 is equal to P1 T2 all over T1. So this is the formula we are going to use. It is very simple. It is very simple. Now, anytime you see a question where they are saying find pressure, just know if you only have temperature and pressure given, they are asking you a question from this law, and so the formula should come offhand. It's very simple for you to understand. So let's quickly substitute. So we have P2 is equal to, what is our P1? The pressure given is 2. So we have 2 times, what is T2? T2 is 450. 450 all over T1. T1 is given as 300. 300. Yes. So what we have here is 2 times 450 is 900 divided by 300. So the final answer will be 3 atm. So this is the final pressure, and we have answered this yesterday. I've provided an answer to it yesterday. In the options given. So for those of you that didn't get it, please note that. Alright, so let's answer the second question. The second question is about the number of molecules and the number of particles. Now this is on Avogadro's law. Let me see question 2 here. Avogadro's law. Okay, now I've explained 2 things yesterday. This law talks both about volume and we have Avogadro's number. Now, remember, anytime we talk about particles / molecules, note that it's not the same thing as moles. But these two are talking about the same thing. Please note that. So, what is Avogadro's number? Avogadro's number says 1 mole of every substance. Note this word, please. Every substance contains 6.022 times 10 raised to power 23 particles. I'm sorry if you cannot remember this in your exams, you may not be able to answer this kind of question. So it is important that you master this number. You should know that the law is saying for every 1 mole of every substance, be it sodium, be it sodium chloride, every substance, 1 mole of it contains this number of particles. Now, let me say this before I proceed. This number you see here, in some books, they write it as 6.023 times 10 raised to power 23. Yes. Now, the reason may be because the next number here is up to 5, so it is approximated. So I want you to note that very, very well. If in exams you see this, please go for it. It's still the same thing with this. Because you may not see this in exams and see this. So don't say, why is it 3 here? And say there is no correct answer. So please use this number. So let's quickly answer the question. The question says, how many molecules of water are in 0.5 mole of water? Now, we know that 1 mole of water has how many molecules? According to the law, it has 6.022 times 10 raised to power 23. Now the question is this: what of 0.5 moles of the same water? How many particles, how many molecules are we going to have? That's the question. So how do we go about this? Now, to go about this, all you need to do is to know the formula and to master it. And this is the formula. Number of particles / molecules is always equal to number of moles times Avogadro's number. Never forget this formula, please. Don't forget it. Once you can remember this formula, you are good to go. So, if you are asked, please just understand these things are very simple. Once you see a question that is asking you number of particles, number of molecules, you should know that they are talking about this. But when you see number of moles, that's another thing. And we are going to look at that. So when you hear number of particles, number of molecules, please note this is what we are talking about. Yesterday, I sent a question on WhatsApp group, a quiz question that some of you answered. And what did I ask? I said 0.5 mole of electrons has how many particles? Do you see? So these particles we are talking about, it can come in electrons, it can come in elements, it can come any substance, it can come in compound. Now the question now, this is asking us of water. Water is a compound. I can say in 1 mole of hydrogen is an element. So this 1 mole that Avogadro is talking about is every substance. Please note that. So having known this formula, I hope you write it somewhere now so that you will use it later for revision. Very important. You need to master it. You need to memorize this question and get it, this formula and get it. Alright, so let's now go ahead and answer our question. We know that 1 mole is always this. So 0.5 mole, according to the formula, if we want to find the number of particles, all we need to do is to multiply the number of moles by the Avogadro's number. So how do we go about that? So we are now going to have 0.5, which is our number of moles, multiplied by 6.022 times 10 raised to power 23. Simple. And please, this is a simple mathematics. This is simple mathematics. I observe that JAMB doesn't even give complex calculations. Some of these calculations, you can do them offhand. You don't even need calculator. And if the less you need calculator, the faster you will be, because you'll be able to finish answering your questions on time. So look at this now. 0.5 is the same thing as half. So if I say 0.5 of 10, this is equal to 5 because I'm trying to say half of 10. Do you get this? And I say if you find a calculations that involves standard form, just keep the standard form aside and deal with those that are not standard form. Or let me better say it this way. Those that have raised to power, those that are raised to powers, put them together. And those that are not raised to powers, put them together and work them out separately. Now, what do we have here? From here, we are like saying half of. Now look at, we are going to treat this separate now. Because this 2 doesn't have any raised to power. So leave this one alone, don't touch it. So if I now say 0.5 multiplied by 6.02, so this will give me 3.011. Let me put it this way. Because I'm trying to say half of this number, that's 0.5. So then I will just drop my times 10 raised to power 23. Do you see that? That is not affected. The standard form is not even affected. So sometimes the standard form is not affected. Just deal with the numbers you have. Is that clear? So this is the second question under yesterday's work. Now let me solve the last one under yesterday so that we can quickly look at what we have today. Alright, the third question says, how many molecules are there in 2 moles of carbon dioxide? 2 moles of carbon dioxide contains how many molecules? Contains how many particles? Please don't forget, when we are talking about these particles, we are talking about molecules. They are the same thing. Don't be confused. I hope this is clear. Now, this is very simple. Since they say number of particles in 2 moles of carbon dioxide, you follow the same formula. What's the formula again? Number of particles is equal to number of moles times Avogadro's number. So you know Avogadro's number offhand, and the number of molecules is given to you. What is left? Number of particles is equal to, what's the number of moles given? 2 times 6.022 times 10 raised to power 23. Simple. this out. So at this point now, 2 times 6.02, you may get something like 2 times 6 is already 12. So we have 12.044 times 10 raised to power 23. This is the final answer. Very simple. You see how I keep my standard form separate and work it out. It's very simple, and simple as this. Now let me explain something here. Now in JAMB, you may not see this as part of the options, because this can further be raised to standard form. This is 12, it's up to 10. So 12 can be expressed in standard form. So, and this is what I mean. If I want to express this in standard form now, it will be 1.2044 times 10 raised to power 1 times 10 raised to power 23. Do you get this, please? I removed 10 from 12. I will be left with 1.2044 times 10 raised to power 1. So this is the 10 here that I have removed. I hope you are getting this. So from here now, I will work this out because the two are similar. So it's just like collecting the like terms. Those that are similar, you put them together and work them out. Now, we have our laws of indices, and I will advise you to visit them because they will help you. Now, in laws of indices, it says if a raised to power n multiplies a raised to power m, that is, the bases are the same, but the powers differ. What did the law say you should handle? How did the law say you should handle that kind of calculation? It says, if it is multiplication, always take one base and add the powers. So it will be n plus m. Is this clear? The bases are the same, so add the powers. These are simple laws of indices. So which means at this point now, the bases are 10, 10, then the powers are 1 and 23. So we are going to take one of the base and then we add the powers. And this will give us 1.2044 times 10 raised to power 24. Is this clear? Now don't be confused. They may decide to leave the answer like this, and they may decide to leave the answer this way. Both are correct. It's just a way to express it, the different way of expressing it. So if they want to leave their answer in standard form, they will reach this point, and this will be the final answer. If they want to leave their answer like this, without expressing all the numbers in standard form, they will also leave it this way. Now, except the number reaches 10 here, you cannot go here. Look at the first one. The first one is 3. So we cannot, this is not up to 10. We cannot express this in standard form. We cannot express this in standard form. So that's why we leave it as the final answer. I hope this is clear, please. I hope it is very clear. If it is not clear, find a way of reaching out so that I can see how I will explain more. So let's quickly run through a few more examples. Let me clean the board. All right. So under concept of mole or mole concept, let me still make a little clarification. Now, we have known how to calculate the number of particles. Now, what if you are asked to calculate the number of moles? Number of moles is always equal to mass in grams all over molar mass. Never forget this formula. Now, I've given up to like 3 formulas now. I have given P1 over T1 is equal to P2 over T2. I have given number of particles is equal to number of moles times Avogadro's number. So this is the first, this is the second, and now I have given number of moles is equal to what? Mass in grams all over molar mass. So just settle down and understand what you are asked to calculate, what they want you to calculate. So if you understand what they want you to calculate, I don't want you to confuse number of molecules. I said particle is the same thing as molecules. Don't, instead of calculating number of molecules, calculate number of moles. No, understand the difference. So this is the third formula I want you to master. Anytime you are asked to calculate the number of moles, definitely they will give you mass in gram and they will give you molar mass. Simple. Let's quickly take two examples. Alright, so the first example here, I have how many moles are there? How many moles are there in 22 gram? Calculate number of moles in 22 grams of carbon dioxide. Carbon dioxide. Given the molecular mass of carbon dioxide equal to 44 gram per mole. Very simple. Now look at this question. For God's sake, if you know the formula, what will stop you from getting this? And it's very funny that many people avoid calculation questions. And that's why many have low scores in physics. And calculations questions are the simplest questions to me because you cannot fail them. It's not like others that are not calculation that you are trying to, maybe you don't know, you are trying to eliminate the wrong ones so that you can arrive at the correct one. No, this one is precise. You can get it accurately. It's very simple. So let's quickly calculate this now. With this formula already, number of moles equal to, what is the mass in gram given? 22 grams, of course, divided by, what is our molar mass? 44 gram per mole. What's the final answer? 0.5 moles. Simple. So this is the third formula. Let's quickly look at the second example. The second example says find the number of moles in 10 grams of sodium chloride. Yes, 10 grams of sodium chloride, and it is given that sodium is 23, that's the mass number, and chlorine is 37.5. This is mass. Now, sometimes you may not be given the molar mass directly, but you will be given what you will use to calculate it. That's it. Very simple. So now we are not given the molar mass directly, so we are going to calculate it from the masses of the elements that contains the compound we are having. So what is the molar mass now? Molar mass is equal to, for sodium is 23, so we have 23 plus. For chlorine is 37.5, so 37.5. What will this give us? This is 59 or 60. No, it's not up to that. Sodium is what? 5 grams per mole. This is the molar mass. So once you calculate the molar mass, what else? Very simple. Number of moles is equal to, what's the mass in grams? 10 divided by what? 58, which is molar mass. 58.5. What do you have? We should have about 0.17 something. So just use your calculator and you will get the correct answer. 171. I have 171 moles here. Simple. I hope this is clear. Alright, let's quickly go to the next one. So that's that about mole concept. I hope this is okay now. Alright. Okay. Then we have mole to particle. No, I don't think I need to do that. Okay, let me just give an example. Mole to particle is what we have calculated here. That's using Avogadro's number. So that's mole to particle. So I'll just give one more example that is a bit different from what we did there. Now, an example is how many particles are there in 0? This is under, okay, I don't need to write that, please. I don't want this video to be long. So I have 0.001 moles of nitrogen. Now look at this question. We are asked to calculate the number of particles or molecules in this. And it is simple, we already have our formula. So we are going to say number of molecules is equal to what? 0.001 times 6.022 times 10 raised to power 23. Yes, how do you handle this? Now, you express this in standard form. Or you use calculator to multiply. Even if you multiply, you still have to express it in standard form. So, how do we express this in standard form? Look at our decimal point. So, we move our decimal point to the right hand side because we are having zeros. There is no significant figure this side. So, if we move once, 2, 3 until we reach a significant figure. So I have moved 3 times before I reach a significant figure. So this will be the same thing as 1 times 10 raised to power minus 3. I hope you get this. Good. Times 6.022 times 10 raised to power 23. So this is what we have. Now, it's because we move to the other side. If we were moving, I'm going to give an example where we move this way. So this is where our decimal point is. So I'll keep moving until I find a significant figure, a significant number. So, and I move 1, 2, 3. 3 times, so it will be minus 3. Okay, now look at this. We have a mixture of numbers in standard form and those that are not in standard form. Bring them together, collect the like terms. So we have 1 times 6.022 times 10 raised to power minus 3 times 10 raised to power 23. I hope this is clear. Now, let's go back to our mathematics. Remember that law of indices that says if you have a raised to power n multiplying a raised to power m, what do? You just take one base and add the powers. So I'm going to apply it here because this 1 times 6.02 is still the same thing. So I have 6.022 times 10 raised to power. So I'm going to add the powers now, following this rule. So it will be minus 3 plus 23. This will give us 6.022 times 10 raised to power. Now minus 3 plus 23 is going to be plus 20. If you don't know how we get plus 20, I don't know. Alright, so we have negative here, we have number. Let me use this illustration. Let this minus be that they owe you. They owe you 3 and you have 23. What should be the balance? You pay back the 3 and you'll be left with 20. Is that clear? That's good. So let me take the last example under this. Now, the second question says calculate the number of particles in 100 moles of water. 100 moles of water, H2O. This is simple. Now, follow the same example. You have the number of moles and you want to calculate particles. So this gives us particles is equal to number of moles is 100 times Avogadro's number 6.022 times 10 raised to power 23. Simple. Now express this one in standard form too. If you don't express it, this will give you 600 and they will not write answer as 600. They will have to raise it to standard form also. So to raise this to standard form, our decimal point will be here. Because all these are significant numbers. So our decimal point is here, even though it's not written. So I'll move from here, I'll move the decimal point. 1, 2. So at this point, I have a significant number, so I'll stop at this. So 100 means 10 raised to power 2. Simple. If you like, you can put 1 times, it's still the same thing. Then multiplied by 6.022 times 10 raised to power 23. So at this point, you can now collect the like terms. This multiplied by this. So you bring them together. 1 times 6.022 times 10 raised to power 2 times 10 raised to power 23. What did the law says? When you have multiplication, add the powers. So these powers is not only, it's not negative. So our final answer will be 6.022 times 10 raised to power 25 particles. I hope this explanation is clear now. So we need to move very quickly to the second to the last part. I hope you are getting it. If you are not getting it, please reach out to me as usual, either on WhatsApp or just drop it on comment section that something is not clear to you. I will come and address it. Alright, so we have mole to volume conversion. Mole to volume. Conversion. So we have done mole to particle. There is also mole to volume. And what's the formula? Volume is equal to number of moles times 22.4 liters. Now remember, if you watch yesterday's video carefully and you understood it, I have explained this yesterday. This is also part of Avogadro's law. In fact, this is Avogadro's law under gas. So we have 2 of them. There is one under gas, then there is one under particles or molecules. So under gas, he said 1 mole of every gas contains or can occupy 22.4 liters. So that's what he said. And that's why, just like here, where he said 1 mole of every substance contains 6.022 times 10 raised to power 22, is the same thing also that he means, that he's saying that 1 mole of every gas contains 22.4 liters. Is this clear? So please don't forget, anytime you are calculating volume, you are doing mole to volume conversion, this is the formula. This is the 4th formula I'm giving now. The 4th one, I'm counting them. Know this formula. If you know this formula, by the time you see these questions, believe me, you'll just be smiling. Because they are very simple. Alright, let's look at examples under volume. This is volume. This V stands for volume, is equal to number of moles times 22.4. So if they now ask you to calculate the volume of a gas, when they give you the number of moles, it's very simple. Alright, so let's look at example. They say find the volume occupied by 3 moles of oxygen. 1. Volume occupied by 3 moles of oxygen at STP, standard temperature and pressure. I have said this yesterday. Okay. This is the question now. Is this not too simple? Do I need to work this out, please? And these are the kind of questions you would see. Very, very simple. Alright, so let's work it. So volume is equal to, what's the number of moles given? 3, correct. So we have 3 multiplied by 22.4. What's the final answer? 3 times 2, 6. 3 times 2, 6.8 liters. Simple. Do you see how simple these things are? But if you don't know it, when you see it in exam, you will just be looking at it like this and move away. And you leave marks like that. No. Let's look at the second example very quickly before we move to the last part. Okay. How many moles are present? Okay. How many moles present? Okay, are present in 44.8 liters of carbon dioxide at standard temperature and pressure. Yes. Now observe something, observe something. If you follow our formula, volume is now given, but they did not give the number of moles. Remember I said one formula earlier, I see number of moles. Number of moles is equal to, yes, who can remember the formula? Mass in grams over what? Molar mass, correct. Do you see it now? Now, there is another formula. When you are dealing with gases, we are going to now derive the formula to calculate the number of moles, because this is what we are asked to calculate, the number of moles. And we are not giving mass in gram, neither are we giving molecular mass. So we can use this formula to make a formula to calculate the number of moles. Now, let me say volume is equal to, let me use small n as our number of moles here, multiplied by 22.4. So we are asked this. This is given, but this is not given. So how do we find this? We make it the subject of formula. By doing what? By dividing both sides by 22.4. So this is going to be, volume is equal to n. Okay, if I multiply this, it will give me 22.4 n. So divide both sides by 22.4. 22.4. So 22.4 will cancel 22.4. My n now is equal to V all over 22.4. So another formula to calculate number of moles is equal to volume over 22.4. Now what's the difference? When you are dealing with mass and molar mass, use this formula to calculate number of moles. When you are dealing with gases, where you have volume, use this formula to calculate the number of moles. I hope this is clear. Alright, so now we have derived our formula. Let's quickly calculate the number of moles. N is equal to, what is our V now? Volume is given as 44.8. What is our, okay, Avogadro's constant is given as 22.4. The final answer will be what? 2 moles. I hope this is clear. Alright, let's quickly go to the last one for today. The last one, if you have not liked, you have not subscribed to this channel, I don't know what you are waiting for. You are learning and you don't want to see this kind of videos again. You don't want to finish your JAMB this year. Like, subscribe, and share with your friends who are also preparing for JAMB. Alright, so let's look at mole ratio from chemical equations, which is the last part. Mole ratio from chemical equations. Okay, yesterday I asked a question under this mole ratio. Surprisingly, some of you did not even get it. I gave a formula. I say hydrogen reacts with oxygen to give water. I even balanced the chemical equation, but let's balance it now, because by that you will also learn how to balance chemical equation. So when we are talking about chemical equation, I have already said it yesterday that we are trying to obey the law of conservation of mass matter, which says matter can neither be created nor destroyed, but can only be changed, can only be transformed from one form to another. Now, look at this. If I leave this equation value the way it is like this, it means it did not obey conservation of matter. Let me show you how. How many atoms of hydrogen do we have here at the reactant side? 2, correct. How many do we have here? 2, correct. How many atoms of oxygen do I have here? 2. How many do I have here? 1. Did I obey the law? What I put together is not what came out at the end. I've explained this law very well yesterday. If you did not understand it, go back to yesterday's YouTube video and watch it and understand it clearly. I've explained everything. Alright, now to balance it, we have to make the reactant side equal to the product side. How do we achieve this? We have to add numbers to make sure that each side is balanced. Okay, so how do we add number? We have 2 here. We have 2 here, balanced. Hydrogen is balanced already, but oxygen is not balanced. Oxygen is 2 here, but oxygen is 1 here. To make oxygen 2 here so that it can be balanced with this side, we have to put 2 here. Now we don't put 2 here as subscript. You have to put it here at the front. Is that clear? So now observe that oxygen is now 2. This 2 standing here means it is for both hydrogen and oxygen, not for oxygen alone. In balancing chemical equation, you don't put numbers as subscript, please, or superscript. You put them at the front of the product or reactant. Alright, now observe that this 2 is for hydrogen and oxygen. So it means oxygen is now 2, balanced. Oxygen is now 2, balanced. Hydrogen is 2. Hydrogen here is now 4. So which means, whereas we have successfully balanced oxygen, hydrogen has also become unbalanced. How do we balance it? Okay, now hydrogen is 4 here. We want to make hydrogen 4 here. How do we make it 4? By adding 2. 2 times 2, 4. 2 times 2, 4. Oxygen 2, oxygen 2. Simple. That's what we are talking about when we are talking about balancing chemical equation. Alright, now the question I asked yesterday, I said, what's the ratio for the combination of hydrogen and oxygen to produce water? Simple. What's the mole ratio? Mole ratio. That was what I asked. Now observe that when we are talking about the ratio, we are talking about the number of moles. And the number of moles are always at the front of either reactants or the product. So this is 2 moles of water. This is 1 mole of oxygen. If it is 1 mole, it is usually omitted. I have said this. Or do you want them to write 1 oxygen like this? No, now. Once you didn't see anything, you should know that it's 1 mole. That's what it means. So what's the ratio now for the hydrogen and oxygen combining to form water? The ratio is 2 to 1. Yes. 2 molecules, 2 moles of hydrogen reacting with 1 mole of oxygen to produce 2 moles of. So, and some of you didn't get it. Please understand it and get it now. Alright, let's quickly go. I need to quickly finish up so that I can attend to some other things. Alright, so under this mole ratio from chemical equation, I have a formula which is the last formula I will give. We are on the last part already. So this is given mole all over coefficient of the substance, coefficient of the substance. I hope you know what coefficient means. This is coefficient. Coefficient of water here is 2. Coefficient of oxygen is what? 1. It's not written if it is 1. Okay, it's equal to unknown moles. Unknown moles all over coefficient of unknown substance. Coefficient, I won't write it in full, please, just understand. Coefficient of unknown substance. Okay, by the time we begin to solve, you understand this formula. So sometimes you will be given the number of moles and you will be given the coefficient of substance. Of course, you will know the coefficient of substance because before you start solving, you must have balanced the equation. And that's why we say mole ratio from chemical equation. So from balancing chemical equation, you will get the coefficient of the substance and the coefficient of the unknown substance. This you get from balancing equation. Mole, number of moles will be given. Then you use these 3 to calculate the unknown moles. Let's take an example very quickly. I would still show you another way. There are 2 ways to go about this. Alright, so the question says in a reaction between water and oxygen, between hydrogen and oxygen to form water. So the reaction is 2 is already balanced for us. In case it is not balanced, just know that you have to balance it before you start working. So this is what we have. How many moles of water are produced? How many moles of water are produced? How many moles of water are produced from 5 moles of hydrogen? From 5 moles of hydrogen. Okay, so this is the question. So I'm going to apply this formula. We'll work it out. Then I'm going to show you another way. If you are smart, then you can apply to get it easily. Okay? So this first one, what's the given mole? The given mole here is what? 5. So I will say 5 over, what's the coefficient of the substance? Coefficient of the substance. Now, which substance are we talking about? Water, of course. So what's the coefficient of water here? 2, correct, over 2 is equal to unknown moles. So unknown moles, since it's unknown, let's give it x all over. Coefficient of unknown substance now is hydrogen. They say how many molecules of water are produced from 5 moles of hydrogen. Okay, we know that of hydrogen. So water still remain unknown. Water is the unknown. So here is for both water, number of moles of water and coefficient of water. The water is the unknown now because you see how many moles of water. So water is the unknown. What's the coefficient of water still? 2. Correct. Is this clear? We have substituted into our formula. From here you can cross multiply. So we will have 5 times 2 is 10 is equal to 2x. Good. So how do we find our x? Divide both sides by 2. Divide both sides by 2. 2 will go with 2. Therefore, x is equal to 5. 5 what? 5 moles. Is this clear? Okay. So let's look at another way very quickly. Let's look at another way. So another way is this. If you have, this is the formula, balanced. Now they are asking us between hydrogen and water. These are 2 questions. Now let this equation become a standard equation that we are using. So, and in this standard equation, 2 moles of hydrogen would always produce 2 moles of water. Are you getting this? So I can say 2 moles of hydrogen produce 2 moles of water, H2O. Now the question is that how many moles of water are produced from 5 moles of hydrogen? From 5 moles of hydrogen. Simple. Do you get this? So I use this equation as standard to find out for the other one that is not given. 2 moles of hydrogen produce 2 moles of water. They are now asking me 5 moles of hydrogen will produce how many moles of water? Are you following me? So from here you can now cross multiply. So 2 times x, that will give us 2x, is equal to 5 times 2, 10. Divide both sides by 2. Divide both sides by 2. X is equal to 5 moles. Are the answers not the same? Is this clear, please? Let's take the last example. Okay, now you know. The last example says how many moles of oxygen? Moles of oxygen. They are asking us moles of oxygen needed to react with 8 moles of hydrogen needed to react with 8 moles of hydrogen. Yes, 8 moles of hydrogen. So this is also very simple, just like we did the other one, because this is talking about water. Hydrogen plus oxygen to give water, H2O. So if you balance the equation, it will give you this. So how many moles of oxygen? They are asking us oxygen now are needed to react with 8 moles of hydrogen. So observe that we are going to dwell at this point now. Yes, that's where we are going to dwell more on. Okay, now let's still use this as standard, because in exams I sometimes, if I can follow shorter methods, I go with them rather than applying formula. So we are going to use the other method we used earlier. Remember, water is not involved this time around. We are dealing with oxygen and hydrogen. So this is where we are going to dwell. Now, based on the standard, based on the law of conservation of mass matter, 2 moles of hydrogen, are you following me, needs 1 mole of oxygen. Simple. Look at it from the equation. How many moles of hydrogen react with how many moles of oxygen? 2 moles of hydrogen react with 1 mole. I told you what the 1 is usually omitted. You cannot write 1 there. No need to write. Once it is 1, just leave it that way. Is that clear? Alright, so we have already established this. Now the question is, how many moles of oxygen needed? Now it means the oxygen part is not given, of oxygen needed to react with 8 moles of hydrogen. The hydrogen part is given 8. Simple. So what do? Cross multiply. So this will give you 2 times x, 2x. So this will give us 2x equal to 8 times 1, 8. Divide both sides by 2. Divide both sides by 2. X is equal to 4. So 4 moles. And this is simple. So you can see 2 react with 1. So 8 will need 4 to react with. Is this very clear? So thank you once again for joining me in this class. If you are not subscribed, subscribe now. Hit the subscription button. Like this video. Let other people see it. You have friends, share with them. Thank you very much. We'll meet again in the next class. Bye.